Coming up on the next episode. Good afternoon, YouTube. It is 2:01 now on this Thursday afternoon. I'm here with you at my usual location. I thought we would do this for a change because this video is going to be a multi-part video. For sure, this part is going to be one part. There is a part on the Baylor 6 radio, the little bastard, where I explain basically the circuit flow and things like that of it before we get into it. And I also wanted to kind of explain some things here that's going on. This may look like Pac-Man, but it's not. This is the first print of the new design I came up with for transistor radios. Now these pieces will fit together. This is the slide. This is the piece that slides back and forth to clamp a new radio circuit board in. And like I said, this is that part, and the big part is printing right now. And I think it was an 8-hour print by the time it's done. But the idea will be, once it gets done, is that it will fit in this and be able to be used to flip the radio back and forth around, and any way I need to do it. Also, as you'll see, I will flash up pictures of this. You will see that there is a cutout for a speaker to be mounted in this device as well. That way you don't have the constant tugging on wires and pulling out the wires. I think I mentioned on the North American, I resoldered the wires 2 or 3 times on that, and this will eliminate that. All the wires will be stationary with the on the board itself, and it'd be easier. You can flip it, either way you need to. You need to get to the circuit side to desolder something, you can do that. You need to the component side, you can get that. You can flip it around any way you need to, and it will be easy enough to power as well. Anytime I want to test, just add I've got my this is my little lead I've got set up for the 970, where I can just plug in this to power the radio, and that will be handy as well. So trying to come up with something, and because I figure, that was one of the reasons I wanted to do this, was because if I want to work on a transistor radio, that makes it much easier to do. And that way, for these side projects like the transistor radio, and that's what it is, I can use it. So that's what I'm doing on that. Now I've got the camera. This is the new PlaySport camera that I'm using to record this. I have not upped the volume level on the mic gain, and I'll probably have to do that in post. But otherwise, it's recording now and should be fine. I've got my ZE1 recording something in the living room. An event going on across the street. People there are moving, and I thought it would be kind of interesting to do maybe a time lapse of that, and we'll see that, and that's kind of neat. So you know me, I like the way I make videos. But so like I said, this print is going on in the living room, and it will take a while. While I was out there, this is going to be a fun print because I'm printing this on its end. This is 190 millimeters tall, the way I'm printing it. So it will be interesting. I was out in the garage looking for tape. I have some the blue body tape, car body or auto body tape out there, and I couldn't find it. So I came in and I found some packing tape, and I'm using that to try to secure. I print a raft at the bottom to give it a little base to it. But that tape will help a lot, I think, I hope. and keep it from tipping over or get knocked off or anything like that. So I hope that's the way it works. Now, while I was out there, one other thing I found, this bag of, I have been looking all over for this. I have been looking high and low and low and high, and how it got where it was at. It was sitting on the floor out in the garage by my toolbox. I have no idea how it got there. No idea, but I found it, so that's good too. Also, while I was out there, I found the wiring I'd looked for when I was doing the wiring on the MFP. I'd looked for this wiring here. I think you can see in there. This is the wiring that came from the dryer itself, and I thought, well, that would make a good wiring for the MFP, and it would have if I'd have found it. I just now found it. So anyway, that's found. So that's two things. Next up, Brendan. You all know Brendan, and I got to find something different to say for Brendan because I use that with Bob. You all know Bob. But Brendan has suggested a new, well, I call it a project or an experiment. But anyway, it involves a radio. Yeah, radio. And it is going to be one that I have acquired, don't know how many months ago it was. It's been a while, but I didn't say a lot about it, but I did acquire this during the stimulus period that I had some extra money, and I've been wanting a radio like this to play with, and he wanted something that had basically a tuned RF stage to it, and because we're going to be doing some experiments with the antenna here to see if we can improve the reception that I get here in the shop. Most of you guys know I get one station, and that's the local station here in town, and that's about it. On a good day with a good radio, sometimes I can get maybe WHS out of Louisville, 84, 840. That's rare these days. So anyway, I do have my active loop, my TechSun active loop that I told him I bought, and he said, well, we could play with that, see. And we're going to try to do that. And then Don of Restore Old Radios fame has been doing his Q multiplier, and I kind of want to do that as well, and examine, does it work well with that, or does it work better with the active loop? Can they be used together? All that stuff. So let me cut this off here, and we're going to introduce you to the prime suspect or prime candidate, whatever you want to call it, for this little experiment. So stay tuned. Alright, well, as you can see before you, this is the Ward's Airline radio that I bought. It is an Airline Global radio. Obviously, Bill, can you see that dial pointer there? I'm going to guess that doesn't work. I don't even know which one of these knobs do anything, but that is the van switch, I do believe. This is AM and shortwave, and that will be a fun radio to play with this antenna thing on. And so there it is. Trying to think of the model number. I will flash the model number up for this radio so that you guys want to follow along with your schematics or whatever. The schematic for this is available online. I think I got it at Nostalgia Air, I believe is where I got it. But anyway, this is the one. We're going to take it apart and look at it a little better as far as the chassis is concerned. And let me get that turned around now, and we'll do that. Alright, well, there is the chassis. I don't know how well you can tell it, but that is broke there, so that's going to have to be repaired. That's not a problem, but like I said, I kind of wanted to take this back off and maybe get at the insides a little bit and look in there, if nothing else, and see what's in there. Well, this one is broke off, so let's see if we can get that up over that like that. This one's not holding anything. This one is. See if I can get that off with this screwdriver here. Alright, there you go. The antenna is on the back, obviously. And that will be easy enough to remove when we get this out. I was hoping, and yeah, it does. I thought it had a 3-gang tuning capacitor. And let me put some light on this and see if we can see inside here a little bit better. Oh, I'm going to light it up. There we go. That's better. Yeah, you can see there's a 3-gang tuning capacitor. That's good. Obviously, this is a transformer set, so it's not a line voltage set, but still, it's oh, there it is, 35WG1573B. So there you go. There's that. Like I say, I probably already put it up there, but speaker looks to be in pretty good shape. I don't see any problems with it. But anyway, this is what we're going to be working with. And yeah, look at that dial string back there, Bill. Can you see that? Whee! That looks like some fun, huh? Yeah. So it may be a case of where it just came off or something. It may not even be broke. We'll have to look at it, but I will get this out of the chassis at some point, and we'll continue our look at it. Let's see if I can get this. I don't know if that's any better or not. Trying to get this in the ways, or in the place where it's not in the way of the camera, but at the same time lights up everything. So looks like miniature tubes and an octal, 2 octals. So that'll be fun. But this is basically what we're going to be using for our antenna experiments, and hopefully this will provide some good gain on the RF. I do believe it has a dedicated RF amplifier in it, tube, so that should be good. Alright, I'm going to put this back down here. Just going to lean it over there and talk about something else. Well, anyway, that's what we're going to be doing with this, and I figure I'd go ahead and tell everybody about what's going on with it, and in addition to the talking about the transistor radios. So that's that. Again, the transistor radio thing's going to be, as time allows. I was telling Brendan that those are just kind of time waster things for me, as far as when I'm not doing anything like this, working on something I consider important. I was looking for a set that met Brendan's criteria. He wanted something that was either an AA6 radio with an RF amplifier and maybe a 3-gang tuned RF stage. And the only radio that I could really come up with that fit that completely was the Philco that Bill sold me, the 46350, I believe it was. That radio actually is AC/DC, and it's a tuned, I think it has 3-gang tuning on it, and I know it has a dedicated RF amp, so we may play around with that as well. I haven't done anything with it since I got it working, and I was going to do the cabinet and never got around to doing that. You know me, so I do things as things hit me or whatever. Anyway, let me show you this a little bit closer on this too. I can't see if you can see that really good, but inside there that's a stair step type thing in there, and I put that in there so you can put a board in there and have it basically clamp onto that board, whatever dimensions it is. I think you can see it that way a little easier. But and the other end is the same way. It has the same type of setup. And again, that should work out rather well. I have on the other end, as you may be able to tell on the picture I put up, there will be a slide on each end like this that it will slide into, and that will keep it from coming out. And this end will have a set screw, that wing nut, and it can be, as soon as you get it in where you want it, clamp that down, and that board should stay there. And so that's the plan. Again, like I say, that will allow me to set that whole circuit board tester aside with the board on it, and like I say, if something else comes along that I'd rather work on, like this, and I can do that real easily, and that's the plan. So that's that. I noticed the new item for the MFP, the signal generator and frequency counter, I believe has left China. I don't know that it's arrived in the States yet, but it's getting closer. So they're saying, I think, we looked at that timeline, I think June the 5th, I think is the earliest it probably could get here. So sometime around then is when we can expect that. Today's the 3rd, I believe. Yeah, and so basically, you know, maybe by Monday. We'll say Monday, because I don't see it getting here before then. But that's just that. And like I said, that's just the way the world works, I guess. Anyway, like I said, this is going to do this. I will take you now to the explanation of the Little Bastard circuit. And once we do that, then I'll probably close out from there. And you guys have a wonderful day. And we'll see you later. So for this video, we're going to be taking a look at the Baylor 6, or aka Little Bastard radio schematic, courtesy of Sam's and Tim Dockery. The date on this is 1962, so this is pretty typical Japanese transistor radio. We're going to take a look at the circuit flow, basically how it's received and how it works and things like that. So basically, over here we have the loop stick antenna. That is our reception for the radio signal, which comes into the base of this transistor here, which is the converter, mixer, oscillator, however you like to say things like that. But basically, this incoming station, whatever we receive, is mixed with the oscillator signal and transferred over to the first IF transformer. Some people might like to think of it as an IF filter. Well, you can think of it however you want to. It's tuned to 455 kilohertz, or kilocycles as it says here. Again, that's filtered there through that. Goes into the first IF amp. This has two on this little radio. This is a jam-packed little circuit, let me tell you. So it is again filtered here at the second IF transformer and fed into the second IF amplifier. And then it goes into the third transformer, where it is once again filtered and detected or demodulated, however you like to look at that. It's done by a single diode here. Now, a lot of these transistor radios from Japan and that era used a transistor to do that. They just shorted the two leads together on one and did it that way to get their transistor count up. Now, this is only a 6 transistor. I doubt that it does that. It probably uses a diode, because it's not really one of the typical ones as far as trying to get that transistor count up. So from there, the demodulated or audio signal, which is what that is, goes over to the volume control. The volume also feeds back or not the volume, but the top of the volume. It comes off of here, feeds back on the AFC, and that's fed back into the previous stages to adjust the gain on the to control the ABC or AGC, however you want to say that. Anyway, that's how that's done. This is the coupling cap from the wiper of the volume control. Now, if anybody's been following the North American series, that's same thing there. It uses a coupling cap to couple the signal to the driver transistor right here. The driver transistor feeds the interstage or phase inverter transformer here. What this transformer does is basically splits the phase of the signal input, puts a positive phase on one, a negative phase on the other. That's the lack of a better term. It's not really, it's oversimplified, I understand. But it just basically puts these two signals out of phase from one another to work with the push-pull audio output. And from there they are combined into a single output from the collector of each. The emitters are generally tied together as they are here. Now this one goes to a ground with a resistor off a resistor, and I think the one on North American uses power. It just depends on how the circuit is, PNPs, NPNs, things like that. But anyway, it's fed back into another output transformer. And again, it is the center tapped, and it feeds into each end, and you get the solid in-phase signal then coming out that goes into the speaker. That's how that works. That's pretty simple. The power supply on this is simple. On this one, it just has a 9-volt source. It looks like, or a minus 9-volt source, and a minus 6.5-volt source. It's really all you have. Sam's uses the numbering system 32 and 7. So anytime you see the 7 or the 32 up here, you will know that that's where that comes from. And that's an easy way to follow it, I guess, is how you look at it or whatever. But here's your 32 here, 32 here, your 7's here, 7's up here. You know, you see all different places for all the shows you where they come from. But that's how they do that. So again, that's how this works. Now this particular radio, the report was that I got from the seller of the radio is that he changed the capacitors in there, and you know, people don't say it, but usually the E caps is what they're changing on the transistor radio. And for some reason, I don't know why, he used a tantalum replacements on this, and I'm not a big fan of tantalum, I'll tell you right off the bat. And I probably will go back and just put E caps in for those, because like I say, I'm just not a fan of the tantalums. And I'm not really a fan of the way he did it, but like I say, that's his, you know, it's his way. He can do whatever he wants. So, plus I am not a fan of just replacing all the caps at once. I like to find out what the problem is first. In this case, I'm going to have to go ahead and replace them because obviously, you know, it's already been done. So you really have to find out if that's the problem or if there is another problem with it. And that's what I'm going to do. Now, for signal tracing, plan is take the signal tracer, hook it up to this point here, say 21, and we will listen for the radio to work. In other words, we'll have it hooked up to power, and if the radio is working, the radio portion, we should be able to tune in our local station with no problem. And that will be a very big key to letting us know where the problem is with this radio, because if it doesn't work, then we can go ahead and take the same point and feed in a signal from our function generator, just an audio signal, and see if we get anything out of the speaker. That will tell us if our audio section is working. So if neither one of them works, then that's when you start looking down here. You check your sources, make sure your sources are right, and then check some points on the circuit board, like these 7s, find out if there is actually 6.5 or minus 6.5 volts there. All of these sections need to be checked. Now, in a case that the whole radio is dead like that, generally it's in this part of the radio, there's something that's not getting out that should get out. And as you can see here, if one of these sources get out, sometimes one section of the radio might work and the other one might not. You have the 32 volts here, and that's going to get your power to here, and you have 32 volts there. So that's going to give you the power to the outputs, and like I said, you should be able to hear some clicks of the power button, and you should hear maybe even some static or something in the speakers, or a little something anyway, if that source is there. So again, that also depends on the E caps. Make sure they're there. Basically, the E caps, this one here couples the signal from the volume control. If this one is open, you won't have any output at all from the what do you call it, because the signal can't get from here to here. So, you know, that's how you know that problem might be there, and so you kind of tend to look at that. But for the most part, these E caps are in the audio section. Looking around at this, I'm not seeing a lot there. I actually see one over here in the radio section. So there's 2 that I found so far. I don't see, and I get you guys are probably laughing at me and say, "Yeah, they're there." I'm just not seeing them. But I know there's more than 2, because I have seen, oh, there's one right there. That's probably the ABC or something capacitor.
So there's 3. Probably some in, yeah, here's one in the power supply, 4. So right there you got 4. The main one that you would have to address though for your audio output is this one right here. You want to make sure that one's good. These are probably disc caps here, and I don't see any other E caps here. Oh, there's one right there, a bypass. So that's another one you can check. But again, so that's 5 that we've found so far. That's probably all of them, I would say, close to it anyway. And so, like I said, those the ones you really want to concentrate first, or I like to. Now, this is one of the things I'm trying to do on this North American radio. As I'm going to try to do a side here as I'm doing this, is concentrate on this part here, the audio. If you can get the audio working, you have one less big problem. In other words, this radio is divided into 2 sections basically, the audio and the radio. And if you get one section working, and then that makes it easier to get the other section working because you've got this one working, and you can use that instead of having to drag out the signal tracer every time you want to test something and see if it's working. But again, like I said, that's just a good way of doing it, my thinking, because this is generally, and I'll use that term loosely, generally the easiest section to get working. Obviously, I think that should be obvious, because you're not working with RF over like you are over here, and it's just audio, and it's pretty easy to be able to tell if it's working or not. And like I said, there's not a lot of components over here compared to the transformers you have over there, and the IF transformers and the oscillator and things like that you have over in the radio section. It's a lot more complicated. This is a basic audio amplifier, and it's pretty easy to troubleshoot. Once you get that working, then you can go from there. But that's my choice. You know, everybody's got their own way of doing things, and that's just my way of doing things. So that is going to serve as our introduction to the Baylor 6 little bastard radio. I just wanted to do these. I'm trying to do these in a systematic type way in order to get this fixed. And as I stated with the North American, these are going to be type rainy day projects, whatever you want to call them. Projects to work on when you don't have anything else to work on as far as tube stuff. And that's what I'm going to do that with this one as well, because I just transistor radios, and Bill knows this very well, they're very tedious to work on, and you can't go whole hog on them the way you would on a tube based stuff, because it's just not that. It's really all too compact, and you'll get your mind in a twist, or at least I do. I don't know, maybe some of you younger guys out there can handle that, but I get my mind in a twist when I try to think all this stuff at once. That's why I try to separate the stages into this, and it's easier to think about this simple circuit here than it is the whole radio all at once, and you know what I'm saying. It's just an easier way of doing it. So, also, in conjunction with this, I'm trying to develop and I have no idea how I'm going to do this, but it's just a thought that entered my head while I was taking this radio apart. It would be so nice to have a holder for these radios. These radios, once you take them out of the case, you guys that work on these things regularly know how easy it is to break leads off on these radios. It would be so nice to have a holder that would hold the circuit board and the speaker and keep them in place, and then allow you to turn the board over and flip it one way or the other without dangling the speaker off the leads and things like that. It would just be so handy to have a circuit board holder and a speaker holder that would keep all those wires intact and not stress them at all, and to still allow you to turn the radio over to solder a component in, or to check its position, or any other thing like that. I just think that would be a great thing to have, and of course I'm thinking 3D printed type of device of some kind. So looking at that, been thinking about that a lot since this North American thing came up, and I thought, man, it would be so nice to have, because I've already soldered the leads onto that speaker twice now on that speaker connection where it goes down to the earphone jack. And I've also, as I mentioned in the other previous video, the minus on the battery connection came off, and I misplaced that and got that in the wrong spot. I've got it back now right, but again, that's just you know, something that would be so handy to have when working on these, and I'm going to try to develop that as a sideline as well. I know I've got a lot of projects going and stuff like that, but that's just the way I like to work things, and again, that's just the way I like to do things. So we're going to try that and see. But as for this radio, that's my plan of attack on it, and you can see the by the schematic that it is you know, a typical Japanese radio. You can almost always tell these push-pull audio outs on a Japanese radio. They're pretty much all the same. It just, again, as far as the power requirements are different, because this one uses ground for the this part here, and uses power for the other part, and the other radio uses just the backwards of that, you know. So it's just, they all kind of use the same way of doing it. They may switch the power and the ground around, but other than that, they're all pretty similar. And you'll notice these are all NP or PNP transistors. These are germanium PNP transistors. That was another common trait of the early Japanese radios. So, all right, gonna get off here and get back to the other portion of the video. All right, well, as you can see, I have finished the talking about the little bastard, and that was done recorded on Wednesday before I did the first part of this video. So that's why I was talking about the transistor radio holder in that form, because I hadn't actually came up with the design yet. So that works out pretty good, I think, the way it's coming out. So also I will tell you that I had to stop the print for that. There was a problem when I went to add that tape. I paused the print. Now, you're supposed to be able to pause the print and then it'd have to take it right back up wherever you left off. Well, it didn't work that way. So it started moving the head around, but it wasn't putting out any plastic. So after doing that for about a half hour, I realized that it wasn't actually printing anything. It was just moving around, and so I have started it over again. So anyway, I've got one piece of tape on it. Hopefully that will be enough to get by and get that all printed. I'd like to get it all done and try it out and see how well it works. It would be nice to know. So, all right, that's going to do me for this little video. You guys, it's going on actually past 4 now. It's 4:04 in the afternoon, and you guys have a great day. Thank you so much for watching, and we will see ya.